Welcome back to today's video, and today we'll be talking about basically the rest of the scalar types, which include floating points, booleans, characters, okay, and numerical operators. And we made sure we broke them down into basic relatable applications, okay, so that you can be able to understand what it is and what it is not. So as much as possible, stay tuned throughout this video and you'll be able to grasp in full what these components are. And mind you, these are things that will actually harm us as we start exploring blockchain technologies in the future. So as much as possible, do well to follow suit, guys. See you guys in the video.
Okay, guys. What we will be talking about is to finish the remaining scalars that we started with integers, and we focus on integers majorly because of what the role it plays generally. So today we'll be talking about the remaining three integers, scalars, which are floating points, booleans, numbers, and characters. Okay, so let's go ahead and wipe this off. What we do is just to clear this, and we start with floating points. We start with floating points. So by the way, this is our comments. So if you want to comment anything else, this is what you do: forward slash, just forward slash to comment anything you want to comment. Which maybe you want to comment a line of code. This is what you do: use forward slash to comment a line of code if you wish to. So these are basically what comments are for, and I'll talk about the other as we move on in this course. Okay, so first of all, understanding floating numbers with analogy is actually the best place to go. Okay, is actually the best thing to do so that you get a grasp of what floating points are and what they are doing and what they are not entirely. I hope that makes sense. So imagine you're measuring the weight of different fruits in a grocery store. Okay, if you use a digital scale to measure the fruits, the weight of the fruits, okay, they display values like 1.5 kg, 2.7 kg, let me just write it down, 3.5 kg, let's say 1.2 kg, and the likes of it. Okay, rather than whole numbers like 1 kg, 2 kg, okay, the digital scale displays a fraction, okay, after the whole number, okay, and this ability represents fractions and decimal values, and that's what we call floating points numbers in Rust programming language. Okay, floating points numbers are just numbers that has decimal point, fractions like 0.5, 0.6, 0.55, 0.54, 0.12, or 1.5, 6.5, any fraction at all that is not a whole number. That's what floating points are. Okay, and also, as we have in integers different box sizes, okay, we also have in floating points different box sizes, but the box sizes in floating points are limited. They are just two, okay, while in integers we have more than two box sizes. Remember the analogy we use in integers, and if you not watch the video, do well to go ahead and watch the video. So we talked about f, u, and I on sign and sign integers in integers. Okay, we talked about I8, I16, I32, I64, and 128. Okay, but in floating point you just have only two. We have, let me just clean this. We have F32 box size. Remember the box size analogy? We have F64 box size. And so this now, the difference between F32 and F64 is the sizes or the content, the size of the content they store. But generally what they only store is whole fractions. Okay, decimal points are not whole numbers. Integers store whole numbers while floating points store fractions. Okay, the difference between F32 and F64 is the amount of content they store. Okay, I hope that makes sense. How that makes sense. Okay, so you can think about F32 as using a basic kitchen scales. Okay, as you mentioned earlier, that gives you the measuring and rounding it up, okay, to a decimal place. So basically, this is what floating points are. Okay, and these are the sizes that you find. These are the two sizes that you can find in floating points when you come to Rust programming language. Okay, so but let's just write some code to expatiate on this more. Okay, let's write some code to expatiate on this more. Okay, so let's see, let x equal 2.0. Okay, let x equal 2.0 and let y equal 3.0. Okay, and you know, let's let me save this. Okay, so I'll just give this a box size of F64, and by default, assuming you don't explicitly add these data types. Okay, remember what we are dealing with are data types. Okay, assuming you don't explicitly add this data type, Rust automatically adds this F64 for you. Okay, it's the default data type when you are talking about floating points. The same way integers, the default uh, the integer type is I32. That's the same way floating point has F64 as its default data type. That's if you don't explicitly tell the compiler the data type you're using in the floating point, okay, or in the decimal F32. Okay, we are telling the compiler the box size we are actually looking at here. Okay, we want to store this in a box size of this, and we want to store this in the box size of this. Okay, I hope that makes sense. That really makes sense. Okay, and let's just try to print this out and see what it will give us. Let's try to print this out. Print ln. Okay. Uh, so let's just do something. X. This is x, and this is y. This is why are you running? So so this is x. We're trying to write a variable here, so we are calling this variables. Okay, so what we just do is cargo run and press enter key and wait for the compiler to compile this code for us, and we'll be good to go. If all our setup went well, it will compile our product for us. Okay, so this is x x2 and x3. And question, there was a decimal point behind it. Why did it round up to 2 and 3? Okay, why did you round up to 3 when we are talking about 3.0 and stuff like that? So Rust follows the IEE 754 standard for floating point arithmetics. Okay, and it means that it can handle decimal point efficiently, but operations involving floating points might introduce small rounding errors. Okay, and due to how this is actually due to how computers store these numbers in binary. Okay, but let's say we change this one to 0 to 1 and see what happens. And we just see what happens. So this printed out 3.1 and this still remains 2. So this is just why it's because of the standard Rust follows. That's why there is a small rounding of errors here and there when you're talking about floating points. I hope that makes sense, guys. Let's talk about numeric operation. Okay, numeric. So at any point you have any question, please do to go to the comment section and ask your question. Okay, I'll be there to actually reply your questions. Okay, numeric operations in ROS. Okay, so when I'm talking about numerics, think about numerics as arithmetic operations. Okay, let's just think about it as different kitchen tasks. Okay, for instance, you're trying to add ingredients together, you're trying to remove, or you're trying to take out excess ingredients from your meal, that will be subtraction, or you're trying to double a recipe so that it can actually reach much people, and that's multiplication. Or you're trying to divide a cake so that it can go around, that's what we call division. Okay, and also we have remainder. So after sharing the cake, what remained? Okay, if there is nothing remain, it's fine, there is nothing remain. Or if there is some parts remaining, that means we have maybe 2 parts or 3 parts remaining. Okay, that's just, we can just use that to try to understand what numeric operation are. So numeric operation, we actually have a few of them. We have addition, addition, we have subtraction, we have subtraction, we have um multiplication, we have division, we have division, and we have remainder, remainder. So let's quickly let's just write some code to explain all this. Okay, just write some code to explain. So this is just basic arithmetic operation, basic mathematics. You're adding, you're subtracting, you're multiplying, you're dividing, and you're getting the remainder of a product. Okay, so let's say sum is addition. Let's sum equals 5 plus 10. Let's sum equal 5 plus 10. And let's difference is actually subtraction, equals 95.5 minus 4.3. Okay, so let's remember, this let keyword is what we use to declare a variable. Okay, it allows us to declare a variable. Okay, let product equaled 4. Okay, let product equaled 4. Product, if you're talking about product, we're talking about multiplication. 4 times 4 or 4 times 3. Let's just leave it 4 times 3. Let's quotient, if you're talking about quotient, you're talking about division. Talking about division, quotient equal, let's say 43 divide, this is the division sign, divide 5, and let's remainder equal 43, and this is the remainder sign, divide 5. So let me just explain what this thing is doing. So now here, remember, we are it's just looking as if you're writing the same thing here. Okay, so what you're saying is this. You just doing as if you're writing the same thing. What you're saying is this. This quotient is dividing. So we want to get, if we divide 43 by 5, 5 people divide 43 items, how many will they get? What will be able to go around equally? Okay? What can go around equally? That's what you're talking about here. But if you're talking about remainder, what you're talking about here is after the whole product have gone around, what is actually remaining? Okay, after the whole product have gone around, what is actually remaining? So we just call the macro here using println, and okay, some um difference product product um, quotient, then remainder, remainder, remainder. And so here now what we do is to remember what we do is just to call this product. Okay, just call this product here. Just add the variables here. So we just start with, I just copy them. Just copy them. Oh, let me just type them plus some some difference difference product. Okay, product product quotient and remainder. So let's close it and do cargo run and see what will become of our products. Okay, so as you can see that when 43, so I'm interested in these two because it's a little bit confusing sometimes, the quotient and the remainder. So this one can be much more easier to explain if 5 and where is it, if 5 and 2 add, they will give this. Okay, then this will be minusing the two fraction will give you this, multiplying this and this will give you this. But the quotient now is that we are dividing these two products. Okay, 43 and 5. You're using 5 to divide this 43, and what went round was 8. Okay, and this remainder now is what is remaining after the 43 have gone round, and obviously it's 3 that is remaining. Okay, I hope that makes sense. Okay, so that's that for what is it called, for numeric operation. And a quick takeaway is that when you're talking about numeric operation uses numeric operation in terms of reminder, they use the percent sign for the this percent sign, this sign here, for the for getting the remainder of a product. Okay, and this comes in handy in the subsequent videos. Okay, so this is all you have to know about numeric operators. So let's talk about booleans. Booleans. So think about booleans like a switch. Okay, is if it's just like someone asking you, if there is light, turn on the switch. If there is no light, don't turn on the switch. Do something else. That's turn off or leave the light on something. It's just like it's a piece of instruction. If something is true, do something. If something is not true, do something else. Okay. So the two key products, or the two key values or keywords that we use in boolean are true, and the true are all in lowercase, and false, and the false is also in lowercase. Okay, true and false. And this is the symbol when you want to use it. You're talking about data types, and you're talking about data types. This is what you use when you're talking about booleans. Okay, the same way we use U32 and F32. That's the same way we also use the bool to represent the data type. Okay, you're telling the compiler that we want to use a boolean here, and not and not a integer or a fraction. Okay, and sometimes the compiler can figure it out for us and just make our life a little much more easier. Okay, so what we will do here is just to write some code to illustrate what we are talking about. So let's just declare some variable. Let t, which is true, equal true. Okay, just a simple let f equal false. Okay, so and this boolean also comes in handy when we are talking about if statements. Okay, and we discuss if statements in the subsequent video. Okay, so this is what we do. Let's say if t is equal to, or let's just write this, if t, so we are saying if true, if t is equal to true. Okay, print ln print ln and just say something nice. The value is true. Else, so if the t is not there, the value is false. Because I hope it makes sense. Else, because I will explain it much more better. I will explain it much more better, guys. So print fn the should be semicolon. The value is false. So this is what we're talking about here. So we are saying, let me just get this done. So what we are saying here is that, oops. So what we are saying here is that, let me comment this out. We are saying if true exists, okay, if this exists, okay, print the value. Oops. If you're saying if this variable exists, print this. If it doesn't exist, print false. Okay, that's just typically what you're saying. So let's just run cargo run and see what will happen. Cargo run. I didn't save. So yeah, this is it. Say the value is true because true exists. So let's just comment this out. Okay, let's comment this out. Now the value does not exist. Let's see what it will print out. Okay, it's showing an error somewhere. Let's see what the error is and tackle it at once. So it's saying cannot find t in the scope. So the t does not really exist. And now, because the t does not exist, it's showing an error. Okay, and if we uncomment this and change this to this, what we are really saying is that if f exists, okay, if f exists, print true. If it doesn't exist, print false. Okay, and this comes in handy when we are actually dealing with um products that in blockchain actually. So when we are talking about maybe you're trying to um connect wallet address, or you're trying to maybe sign a contract, or you're trying to validate something, or you're trying to run a loop. Okay, this is where this if statement comes in handy, and we use true or false a lot. Okay, and so this is how true or false works. Okay, let me just try something. Maybe let's just do something a little bit out of the box. Okay, so let's just do something a little bit random and something that is out of the box. We should still keep the variable name and change this to 5, and let's just say if t is equal 5, okay, print true. So we are saying if the value that this t is storing is 5 is equal to 5, print true, else print false. Let's see what this will print, and voila, say that the value is true. So let's change this value to 6 and see what it will print. It should print, probably if everything went well, it should print false. So because the value stored here and these are not the same. Okay, that's what I'm saying. So what I'm trying to say here is that the if statement is actually a crucial thing that you should actually be aware of, and that is simply that for booleans. Okay, and we explicitly talk about if statement in the coming video. Okay, we talk about it in details in the coming video. And so what we just want you to understand is about booleans and how they work. They are just like trying to say, it's just like a statement saying if this is true, do this. If this is false, do something else. If it's true, switch on the bulb. If it's false, do something else. Okay, this is what booleans are for. Okay, I hope that's actually clear. So let's talk about another scalar type, which is character. Okay, so imagine characters are like letters, okay, in a tile board game. Okay, and Ross character type are represented like this. Okay, so if you're talking about characters, they are represented like this. This is the type. Okay, so if you want to write something using the character, and they are just a kind of values, letters, single letters, symbols, and emojis. Okay, these are some emojis actually contains are characters, while some are not characters. And one of the unique feature about characters is that they are actually stored in a single quotation mark. Okay, unlike other like strings that are stored in double quotation mark, and we talk about it extensively. Let's just write some code and explain what characters are. So I say let's see. Okay, so characters are the data type annotation are represented with this. Okay, equal with a single quotation mark, and they store only one an alphabet, a letter, a single letter, and symbols, mathematical symbols, and some emojis. Okay, so that's what they store. So the assignment I want you to do is just to pick up any emoji and just run it and see if it will run. Remember, it will only be a single quote. So if it throws an error, that means you're using a double quote, or the emoji you're trying to use is actually a string type and not a character type. Okay, so let me just run this. Let me just run this, and this is a character. This is a character type. Just store this here. See. Better still, let me keep it consistent, and we just be on. Okay, so cargo run. So you say that this is a character type Z. Okay, so basically I want you to just test run. This is just an assignment. I want you to test run the symbol, mathematical symbol character type, and also the emojis character type. Okay, emojis like the laugh emoji are character types, and also symbols like some mathematical symbols generally are character types also. Okay, while some emojis are exempted is that some are not really Unicode in nature. Okay, meaning that cannot be represented with letters, and they are double quoted in quotes. So that's why they are actually not character type. And so the unique feature about characters is that they are represented with single quotes, and that's how the compiler will know that okay, this is a character type, not really a string. Okay, because you are trying to represent this thing with a string and leave this type annotation here, I will actually bump into a very big error. Let's just try it out and see how it goes. Okay, so let's just try this out and see how it goes. I'll just put this up. So it's saying something here. Oops. Saying something here. So let's just say that expected character found, not a string type. Okay, mismatch type. So data type here is mismatched. So it was expecting a character type, and you're not you're is a character type that you added, but now you're representing this with a string type, which is double quote. That's why it's showing this error, guys.
Okay, guys. In conclusion, floating point numbers F32 and F64 allows decimals, but follow the IEEE 754 rules. Okay, meaning that there is slight precision errors can occur. Okay, we talked about numeric operation, which is plus, minus, multiplication, division, and remainders, which is leftovers, which work as expected. Okay, but integer division truncates values. Okay, and I said if you have any difficulties in that, reach out to me and I will explain to you, or drop a comment in the comment section. Okay, we talked about boolean, which is this is true or false. Okay, and characters in Rust supports Unicodes. Okay, allowing symbols, accented letters, and emojis. So there are some emojis that are not actually characters, that are string types. Okay. So please do well to leave a comment in the comment section if you have any question or any confusion is anywhere, or you have any objection. Do well to drop your comment in the comment section, and I will be there to actually be of help and to hear your view. Okay, and subscribe to this channel and share to your friends. Okay, and see you guys in my next video.